Hi all, welcome to Anil Nair classes. Today in this session, we are going to discuss one of the most important subconcept in number system, that is divisibility rules. Extremely important concept and very important concept from an examination point of view. What is the divisibility rule of different composite numbers? How to derive the divisibility rule of a prime number? All the variety of questions starting from the basic question to the advanced level, we will discuss through this YouTube live classes. Totally 4 sessions I am going to take only on divisibility rules. Ensure that each and every student who is watching the video kindly watch session 1 first, then session 2, then session 3 and then session 4. Kindly do not watch session 4 before watching session 1, 2 and 3. There will be few links that will be missing, thereby your understanding of the concept will be little ineffective. Let us straight away get into the class, divisibility rules. I request each and every student to sit in the class with a notebook and a pen or a pencil. Everything, whatever I am explaining, in addition to the solution, please make a note of it. Generally, most of the classes, there is a question and there is an answer. But in my classes, beyond answer, I will be explaining you the W and H related questions. That is why, what, when and how. What if this value is changed, when this concept is applied, why this concept is applied, how this concept is applied. That is very important for a student to know, so that you can only start creating your own questions. At the end of the session, you will be able to solve most of the questions without the usage of pen and pencils. I will ensure that you use your fullest power of the brain. I will make you think logically, right? Less formulae based content, more conceptual content. Watch the entire lecture. Kindly do not leave the class in between. I will be starting from basics so that you will not miss out any of the important concept. Watch the entire lecture, and to get the best output from the lecture, kindly make a note of the important key points. Mathematical learning can never happen with the screenshots. The best way to learn mathematics is to take a pen and do some pen pushing in your notebook. Even though you are good, right? At the end of the class, I will make you better. At the end of all the sessions, I will make you best. Trust the 15 years of experience. Those of you who are new to me, who are watching my classes for the first time, kindly subscribe to the YouTube channel so that you will not miss any of the class notification. I will be coming regularly on the YouTube channel and I will be taking a lot of YouTube live classes. The sad part about my classes is, right after my class is over, the class will be available only to the enrolled students. Non-enrolled students can watch it only once when the live class is going on. I might have taken more than 500 times, more than 1000 students in a class. Generally, my class will have a huge gatherings of 2000, 3000 students sitting in the class. In case you got any doubt at the end of the class, feel free to mail us at support@anilnairclasses.com. Divisibility rules, 4 sessions. Straight away, let us get into it. Now, those of you who are new to me, right, we are ranked number 1 by Google reviews all over India. 3,643 students has rated us at 4.8 out of 5. Why this many people gave such a high rating? You will understand as the class proceeds. Now, divisibility rules. Divisibility rules. Now, suppose there is a number 12 divided by 3. How to check whether 12 is divisible by 3? Suppose there is another number 6 ones divided by 7. General division, there is one method. General division is very complicated. You have to take the number and you have to do the generic division. This division is a very complicated process. That's the reason, right? We have developed some divisibility rules for composite numbers. Composite numbers is quite easy, right? But I will also be discussing the divisibility rule of a prime number. divisibility rule of a composite number and divisibility rule of a prime number, right? By knowing these divisibility rules, you can check whether the number is perfectly divided by this number, what is the remainder of this number. Your life becomes very easy, unlike going through a generic division, which is a very painful process. By knowing these divisibility rules, you can use the concepts and solve most of the questions just through a sheer observation or sometimes with a little bit of pen pushing. Divisibility rules. How the questions will be asked? Now see this question. There is a number that is given 1, 2, 3, 4, 5, 6, 7, 8, 9. He is asking what is the number remainder when a number is divided by 2, when a number is divided by 5, when a number is divided by 10. Generic division I am not interested. So there is a question and he is asking what is the remainder when the number is divided by 2, 5 and 10. So what I will be doing is I will be discussing the concept 1, divisibility rule for divisibility rules for 2, 5, 10. Divisibility rule for 2, 5, 10. We'll start from basics, then we'll go to the advanced level. 2, 5, 10. If you know the divisibility rule of 2 and 5, automatically 10 will come, because any divisibility rule of a composite number can also be found out from the product of co-prime numbers which results in the other number. 10 is nothing but 2 and 5. So the combination of 2 and 5 will result in 10. Divisibility rule for 2, 5 and 10. Now first we will discuss take a 2-digit number. Let there be a 2-digit number AB. B is there in units place. A is there in tens place. So the value of A will become 10 into A. Because A is there in tens place, the value of A will become 10A. This can be written as 10A plus B. Am I right? For example, 2, 3. 2 is there in tens place. So the value will become 2 into 10 plus 3. Am I right? 10A plus B. Now 10A plus B. Suppose if 10A plus B, if AB is divisible by 2. I said that this 2-digit number is divisible by 2. That means AB is divisible by 2. 10A. 10 is nothing but it is divisible by 2. This number is divisible by 2. This number is divisible by 2. Obviously, B should also be divisible by 2. Why? Because, for example, 20 is nothing but 12 plus 8. 20 is divisible by 2. 12 is divisible by 2. 8 should also be divisible by 2. Again I am repeating, if AB is divisible by 2, any number divisible by 2 is called as an even number. That means if AB is an even number, 10 into A, any number multiplied by 10, 10 is nothing but 2 into 5, that is also divisible by 2. AB is divisible by 2, 10A is divisible by 2, B should also be divisible by 2. B should also be divisible by 2 means B should also be an even digit, or B should take a digit which is nothing but an even number. That means B can take either 0, B can take either 2, B can take either 4, 6 or 8, because these are nothing but the even digits 0, 2, 4, 6, 8. So what is the conclusion that we have drawn from these AB? If AB is an even number, that means B should also be an even number or even digit, because B is a digit, it will obviously take a digit value. That means for a 2-digit number to be an even number, unit digit has to be an even number. Unit digit has to be an even number. Why only unit digit has to be an even number? Because other part is already divisible by 2. Now you might ask me, Anil sir, is this valid for 3-digit numbers, 4-digit number, 5-digit number? Yes beta, it is valid for every n-digit number. Let me take a 3-digit number. Suppose if I take a 3-digit number. Suppose if I take a 3-digit number, A, B, C. A, B, C. C is there in units place. B is there in tens place. So the value will become 10B. A is there in hundreds place. So the value will become 100A. B is present in tens place, so the value of B became 10 into B. A is there in hundreds place, so the value of A became 100 into A. If ABC is an even number, if ABC is an even number means it is divisible by 2. Any number divisible by 2 is also an even number. 100A is divisible by 2. 10B, it is divisible by 2. C should also be divisible by 2. That means C can take 0, 2, 4, 6 or 8. C can take 0, 2, 4, 6 or 8. That means even for a 3-digit number to be an even number, unit digit has to be an even digit. Unit digit has to take an even value. That means for a 2-digit we did it, for a 3-digit. You don't need to do 4 digits. 4 digits means it will become C. B is there in tens place, 10B divisible by T. A is there in hundreds place, divisible by T. E is there in thousands place, 1000 is divisible by T. Any power of 10 from 10 power 1 onwards, 10 power 1, 10 power 2, 10 power 3 and so on. It is divisible by 2. So the only thing that you have to consider is unit digit should be an even number. Unit digit should be an even number. So the first important concept for divisibility rule for 2 is divisibility rule for 2. Divisibility rule for 2 is unit digit should take an even value. 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 What do you mean by an even value? It can be either 0, or 2, or 4, or 6, or 8. You don't need to divide the entire number. Just take the unit digit of that number and divide it by 2. You will get the remainder when it is the divisibility rule for 2. I hope it is clear. Similarly, what is the divisibility rule for 5? Divisibility rule for 5. What is the divisibility rule for 5? Because I explained it 2, right, with multiple examples, 5 I will restrict it. If I take a 2-digit number AB, A is there in tens place, so it is nothing but 10A plus B. 10A is divisible by 5. That means B should be divisible by 5. Example, 25 equivalent to 15 plus 10. 25 is divisible by 5. 15 is divisible by 5. 10 should be divisible by 5. Even if I take a 3-digit number, A is there in hundreds place, 100A plus 10B plus C. 100 is divisible by 5. 10 is divisible by 5. C should be divisible by 5. That means divisibility rule for 5 is unit digit should be 0 or 5. Any number multiplied by 5, it will give you unit digit 0 or 5. 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25. Divisibility rule for 5 says that unit digit of that number should be 0 or 5. Divisibility rule for 2 says that unit digit should take an even value. Even value is nothing but a value which is divisible by 2 including 0. Divisibility rule for 2. I hope it is clear. Divisibility rule for 5. The last one to solve our first question is divisibility rule for 10. Divisibility rule for 10. Divisibility rule for 10. Divisibility rule for 10. Any number you multiply by 10, unit digit will be 0. 10 2s are 20, 10 3s are 30, 10 4s are 40, 10 5s are 50, 10 6s are 60. Let me take an example. AB. A is there in tens place, so 10A plus B. If I take a 3-digit number, A is there in hundreds place, 100A plus 10B plus C. If AB is divisible by 10, 10 into any number divisible by 10, B should be divisible by 10. That means B can take only unit digit value 0, because any number multiplied by 10, unit digit will be 0. If this is divisible by 10, this is divisible by 10, this is divisible by 10, unit digit value should always be 10. Divisibility rule of 10 is nothing but the divisibility rule for both 2 and 5. Divisibility rule for 10 is nothing but divisibility rule for 2 and 5. What is the concept for 2 and for 2? Unit digit should be 0, 2, 4, 6, 8. Intersection. What is the divisibility rule for 5? Unit digit should be 0 or 5. What is common in both? Common in both is 0. That means divisibility rule for 10 is unit digit should be 0. Unit digit should be 0. I hope it is clear. Everything we will do by using proofs. Unit digit should be 0. Divisibility rule for 2 is unit digit should take an even value. Even value are nothing but because it's a digit, it will be 0, 2, 4, 6 or 8. Divisibility rule for 5 is unit digit should be either 0 or 5. Divisibility rule for 10 is any composite number, if it can be written as a product of two coprimes. Coprimes means their HCF is 1. HCF of 2 and 5 is 1. Take the divisibility rule for 2. Take the divisibility rule for 5. Do the intersection of these two. Intersection of these two is only one value, that is 0. So divisibility rule for 10 is unit digit should be 0. I hope the concept is clear. Now the questions can be solved very, very easily. Find the remainder when the number is divided by 2. When you are dividing a number by 2, the focus will be only there on the unit digit. Unit digit is 9. 9 when divided by 2. 2 4s are 8. Remainder is nothing but 1. I hope the concept is clear. Why we are dividing only by the unit digit? When a number is divided by 2, unit digit should take an even value. Question 2. Find the remainder when a number is divided by 5. When a number is divided by 5, unit digit should be either 0 or 5. Only focus is on unit digit. 9 when divided by 5. 5 ones are 5, unit remainder is nothing but 4. I hope it is clear. Question 3. Find the remainder when a number is divided by 10. 10 means unit digit has to be 0, but it is 9. Right? So answer is 9. Right? So if it is 0, answer will be 0. If it is anything other than 0, that will be the unit digit. In this first question, we discussed two important concepts: how to find the divisibility rule for 2, how to find the divisibility rule for 5, how to combine the divisibility rule for both 2 and 5 and do it for 10. Next question, see here. Now we did only the preliminary concepts, that is 2, 5 and 10. What happens if it is beyond 2? In this slide, I will be discussing the divisibility rule for 4, 8, 25, 125, 100 and 1000. 4, 8, 25, 125, 100 and 1000. The first two are for the powers of 2. Next two are for the powers of 5. Next two are for the powers of 10. I hope it is clear. That's exactly the reason why I discussed the divisibility rule for 2, 5 and 10. Second question, I will do the divisibility rule for the powers of 2, powers of 5 and the powers of 10. If I start solving the second problem, first problem, if you know the first problem, understanding the second one is very easy. Vice versa may or may not be true. Find the remainder when it is divided by 4 and 8. Now, next, everything we will discuss the concept first. Divisibility rule for 4, 8. 4, 8. Then we will generalize it. Generalize for 2 power n. Then we will generalize for 2 power 1. Divisibility rule for 4, 8. Now, I will take a 3-digit number. For example, if I take a 3-digit number, if it is ABC, A is there in hundreds place, 100A. B is there in tens place, 10b plus c. 100a plus 10b plus c. Now if you see, if ABC is divisible by 4, if ABC is divisible by 4, 100 is nothing but 4 into 25. This is divisible by 4. 10b plus c should be divisible by 4. 10b plus c is nothing but the last two digits. Yes or no? BC can be written as 10b plus c. That means for a 3-digit number to be divisible by 4, last two digits should be divisible by 4. Last two digits should be divisible by 4. Last two digits should be divisible by 4. I hope the concept is clear. Is it valid for a 4-digit number? A, B, C, D. D is in units place. C is in tens place. B is in hundreds place. A is in thousands place. So 1000 A plus 100 B plus 10 C plus D. 1000 is 4 into 250. 100 A is 4 into 25. 10 C plus D. Again it is nothing but the last two digits. That means for any n-digit number n greater than or equivalent to 3, it could be a 3-digit number, it could be a 4-digit number, it could be a 5-digit number. The divisibility rule of 4 is last two digits should be divisible by 4. Last two digits should be divisible by 4. Last two digits should be divisible by 4. Now, a very important conclusion. I will do it after I discuss the divisibility rule for 8. If I take the divisibility rule for 8, suppose if I take A, B, C, D, 1000 is 8 into 125. That means this entire number should be divisible by 8. Now, I want to optimize a few things. Now, if you see here, divisibility rule for 4. Divisibility rule for 4. What is the answer we got? Last two digits should be divisible by 4. Last two digits should be divisible by 4. Divisibility rule for 8. Divisibility rule for 8. What did we get? Last 3 digits should be divisible by 8. Last 3 digits should be divisible by 8. Can I also write it like this? 4 is 2 square. That is the reason I got last 2 digits. 8 is 2 cube. Last 3 digits should be divisible by 8. 2 power n divisibility rule is 2 power n divisibility rule is last n digits should be divisible by last n digits should be divisible by last n digits should be divisible by 2 power n. I hope it is clear. 2 is nothing but 2 power 1. That is the reason unit digit should be divisible by 2. If it is 4, 4 is 2 square. Last 2 digits should be divisible by 2 power n. If it is 8, 8 is 2 power 3. Last 3 digits should be divisible by 2 power 3. I hope the concept is very clear. 2 power 1 means 1 is unit digit. 4 is 2 square. Square means last 2 digits. If it is 8, 2 power 3. 3 means last 3 digits. 2 power 4, it is last 4 digits. That is how you can deduce the divisibility rule for 2 power n. I hope the concept is clear. 2 power n. Now, let me discuss the divisibility rule for 5 power n. Divisibility rule for 2 we discussed, then 2 power n. Then divisibility rule for 5 power n. 5 power 1. Suppose if I take a 3-digit number A, B, C. A is there in hundreds place. So 100A plus 10B plus C. 100A is divisible by 25 because 100 is nothing but 4 into 25. 100 is 4 into 25. That means 10b plus c. Again it is a 2-digit number. 2-digit number, last 2 digits should be divisible by 25. Last 2 digits should be divisible by 25. Now if you look at the divisibility rule for 5 power n. So we already discussed the divisibility rule for 5, where the unit digit has to be either 0 or 5. If I take a 3-digit number ABC, if ABC is divisible by 25, ABC is a 3-digit number, C is unit digit, B is a tens digit, A is hundreds place. 100A plus 10B plus C. 100A is divisible by 25. If ABC is divisible by 25, 100A is divisible by 25. 10B plus C should be divisible by 25. 10B plus C is nothing but the last 2 digits. Last 2 digits should be divisible by 25. Same concept for 2 power n. Last 2 digits should be divisible by. Last 2 digits should be divisible by 2 power n. Last 2 digits should be divisible by 2 power n. Same concept holds good for 5 power n. 5 power n means last n digits here. Last n digits should be divisible by. Last n digits should be divisible by 5 power n. There is no difference between the divisibility rule for 2 power n and 5 power n in terms of the face value. 5 power n means last 2 digits should be divisible by 25 if it is 5 square. Last 3 digits should be divisible by 125, it is 5 power 3. Last 2 digits should be divisible by 4 if it is 2 square. Last 3 digits should be divisible by 8 if it is 2 power 3. I hope the concept is clear, right? Idea remains the same because 100 is nothing but 4 into 25. 1000 is nothing but 8 into 125. If there is 2 power 3, there has to be 5 power 3 combination. Then only you will get the value of the digit at the thousands place. They both complement each other. Divisibility rule for 2 power n and 5 power n. You don't need to do 10 power n, right? So 10 power n is very simple. 100 into 1 is 100. 1000 into 4 is 1000. That means if I am multiplying by 10 power 3, last 3 digits will have 3 zeros. Last 3 digits will have 3 zeros if it is 10 power 3. If it is 10 square, last 2 digits will have 2 zeros. Last 2 digits will have 2 zeros. I hope it is clear, right? That means the divisibility rule for 10 power n is last n digits should be divisible by 10 power n. I hope it is clear. If you can get 2 power n and 5 power n, 10 power n is nothing but the product of 2 power n and 5 power n. What we discussed is just finding the concept behind the divisibility rule for 4, 8, 16, 25, 125. When we do problems, it will be much more clear with an numerical value example. Now see here. Question. Find the remainder when number is divided by 4. What is the divisibility rule for 4? Last 2 digits should be divisible by 4. Last 2 digits is 189. 189 when divided by 4. 4 22s are 88. What is the remainder? 1. Question 1 answer is 1. Question 1 answer is 1. Now question 2. What is the remainder when a number is divided by 8? 8 is 2 power 3. Last 3 digits should be divisible by 8. Last 3 digits is 789 when divided by 8. 8 9s are 72. 72 69. 8 8s are 64. What is the remainder? 5. Question 1 is divide only the last 2 digits by 4. Question 2 is divide the last 3 digits by 8. Otherwise, you will end up dividing the entire number by 8. You don't need to do it. Find the number when it is divided by 25. 25 means last two digits should be divisible by 25. 89 divided by 25. 25 threes are 75. Remainder is nothing but 14. Question 1 is clear, question 2 is clear, question 3 is clear. Question 4. Question 4. Find the remainder when a number is divided by 125. 125 is 5 power 3. That means last 3 digits should be divisible by 125. Last 3 digits is 789. 789 divided by 125. 125 5s are 625. From 789 625. If I subtract, which is nothing but 164, right? 625 plus 164 is 789. Only the last 3 digits we did it. 1, 2, 3, 4, it is clear. Find the remainder when n is divided by 100. 100 means last 2 digits. When you divide a number by 100, what you have to do is just take the last 2 digits of the given number. When you divide a number by 100, take the last 2 digits from the given, from n. Last 2 digits from n is nothing but the remainder. When you divide a number by 100, last 2 digits is nothing but 89. Answer for this question is 89. Question number 6. When you divide a number by 1000, it is nothing but the last 3 digits from n. Only take the last 3 digits from n. Only take the last 3 digits from n. Last 3 digits from n is nothing but 789. 789. Extremely important set of questions. The divisibility rule for 2, 5 and 10 is question number 1. Divisibility rule for 2 power n, 5 power n and 10 power n is question number 2. These especially 5 and 6 are extremely important when you are doing the remainder, when you divide a number by 100 and 1000. When you divide a number by 100, you will get the last 2 digits of a number. When you divide a number by 1000, you will get the last 3 digits of a number. When you know the divisibility rule for 2 power n and 5 power n, 10 power n is nothing but the combination of 2 power n and 5 power n. I hope set of these 6 examples are very, very clear. Now, next one, we did 2, we did the power of 2. We did 5, we did the power of 5. We did for 10, we did the power of 10. There are certain more composite number that are there. That is the divisibility rule for 3, divisibility rule for 9. Now we will do first of all divisibility rule for 3. What is the divisibility rule for 3? Divisibility rule for 3, 9, 27, in general 3 power k. Divisibility rule for 3, 9, 27 and so on. Example, if I take a 3-digit number A, B, C. A is there in hundreds place, 100A. B is there in tens place, 10B plus C. This can be written as 99A plus 9B plus A plus B plus C. If ABC is divisible by 3, assume that the left hand side is divisible by 3. 99A is divisible by 3. 9B is divisible by 3. A plus B plus C should be divisible by 3. What is A plus B plus C? A, B and C are the digits for the number ABC. What do you mean by A plus B plus C? Sum of the digits should be divisible by 3. A plus B plus C is nothing but the sum of the digits. A plus B plus C is nothing but the sum of the digits. That means for 3 I got it. Assume if ABC is divisible by 9. Left hand side if it is divisible by 9. 99 it is divisible by 9. These also divisible by 9. A plus B plus C should be divisible by 9. That means not only for the divisibility rule for 3 but also for the divisibility rule of 9. What is the concept I am getting? Sum of the digits should be divisible by. Sum of the digits should be divisible by 3 or 9 or 27 or whatever it is, or we will do first for 3 and 9. I hope the idea is clear. 3 and 9 first we will do it, because first the questions are based on 3 and 9, then obviously we can elaborate it for 27 also. Divisibility rule for 3 and 9 is nothing but sum of the digits should be divisible by 3 and 9. Right? For 3 sum of the digits should be divisible by 3. For 9 sum of the digits should be divisible by 9. I hope the idea is clear. If I am doing it for a 3-digit number, the same proof also holds good for a 2-digit number or a 4-digit number or a 5-digit number, so on and so forth. Idea clear? Now we will solve the problems. Question 1. Find the remainder when a number is divided by 3. When a number is divided by 3. 1, 2, 3, 4, 5, 6, 7 when divided by 3. Sum of the digits should be divisible by 3. So take the sum of the digits wherever it is 3, scratch it off. 1 plus 2, 3, cancel. 4 plus 5, 9, divisible by 3. 6 is divisible by 3. 7 divided by 3. 3 2s are 6, remainder 1. I hope the idea is clear. Delete the digits whose sum is 3. Sum of the digits should be divisible by 9. The same thing for also for the number when it is divided by 9. 1, 2, 3, 4, 5, 6, 7 divided by 9. 6 plus 3, 9. 5 plus 4, 9. 7 plus 2, 9. 1 divided by 9, 1. I hope the idea is clear. Question 1, I hope it is clear. Question 2, I hope it is clear. Now see, question 3. Question 3. Find the remainder when a number is divided by 18. 18 can be written as a product of two coprimes, 2 and 9. I hope it is clear. Always whenever a composite number is there, write it down as a product of coprimes. Write it down as a product of two coprimes. Write it down as a product of two coprimes. 15 is 3 into 5. 24 is 3 into 8. 40 is 8 into 5. So 18 is 2 and into 9. Now 2, what is the remainder when this number is divided by 2? Unit digit should be divisible by 2. 7 divided by 2. 2 3s are 6. Remainder is 1. Similarly for 9. 9, what is the remainder? We got 1. That means a number when divided by 2, it gives a remainder 1. A number when divided by 9, it gives a remainder 1. Both are for the same number, right? So equate it. Both are equated with A0 or B0. Am I right? 2A equivalent to 9B. That is only possible when A is 0 and B is 0. A 0. 2 into 0 plus 1. 1. So answer is, the form of the number is, the lowest remainder is 1. Every time it is divisible by 18k. 1 plus 18k divisible by 18. Answer for this when the number is divided by 18 is 1. Again I am explaining you the third question. Third question, find the remainder when a number is divided by 18. First of all, 18 is a composite number. Second step, I wrote 18 as a product of two coprimes, which is 2 and 9. Step number 3. I know the divisibility rule for 2. Unit digit should be divisible by 2. 7 when divided by 2, it gives a remainder 1. I know the divisibility rule for 9. Sum of the digits should be divisible by 9. I did the sum of the digits, I got a remainder 1. Answer when divided by 2, it gives a remainder 1. Answer when divided by 9, it gives a remainder 1. Both are for the same number. So 2a plus 1 equivalent to 9b plus 1. 1 1 cancel. 2a equivalent to 9b. Both are same at a0 or b0. a0, if I did it 2 into 0 plus 1, 1. Answer for this question is 1. What is this 1 plus 18k? 1 plus 18k is the form of this number. 1 plus 18k when divided by 18, remainder is 1. I hope it is clear. Slowly, steadily, we will increase the level of difficulty. We will increase the level of difficulty. We did it for 2, 5, 10. We did it for 2 power n, 5 power n, 10 power n. We did it for divisibility rule for 3, 9 and how to do it for 18. Now, we will do it for 9, 36 and 45. 9, 36 and 45. Question number 1. Remainder when the number is divided by 9. 9 means sum of the digits should be divisible by 9. Sum of the digits should be divisible by 9. That means number is 1, 2, 3, 4, 5, 6 and so on up to 40, 41, 42. Sum of all first 42 natural numbers is summation 42. Summation 42 is summation n is given by n into n plus 1 by 2. What is summation n? It is nothing but sum of all natural numbers starting from 1 to n. So it is 42 into 43 by 2. 2 21s are 21 into 43. You don't need to do it. 2 plus 1, it is 3. 3 plus 4, 7. 3 7s are 21. 2 plus 1, 3. Answer for the first question is 3. Answer for the first question is 3. Sum of the digits should be divisible by 9. 1 plus 2 plus 3 and so on up to 42. Sum of all first 42 natural numbers is n into n plus 1 by 2. So summation 42 is 42 into 43 by 2. 21 into 43. 21 into 43, whatever the resultant digital sum finding is one way, or finding the digital sum of individual numbers. 2 plus 1, 3, 4 plus 3, 7, 3 7s are 21, 2 plus 1, 3. I hope the idea is clear. Now a smart student might ask me this doubt. Anil sir, you said that when you divide a number by 9, sum of the digits should be divisible by 9. But here you have taken the individual numbers. Now 1, 2, 3, 4, 5. If I take it as the sum of individual digits, 1 plus 2 plus 3 plus 4 plus 5. What is the sum of the digits? 5 plus 4, 9, 9 plus 3, 12, 14, 15. 15 digital, it is 6. Suppose if I take it as a group of 2 digits for 2, 3 and 4, 5. 23 plus 1, 24. 24 plus 45, which is 16, 9. 6 plus 9, 15, which is again 6. Suppose I take it as a group of 3 digits. 1 plus 2 plus 3, 45, which is 348. 3 plus 4, 7. 7 plus 8, 15, again 6. Suppose I take it as a group of 3 digits. 123 plus 45, which is again 168. Again the digital sum is 6. So instead of taking individual digits or a combination of 2 digits or a combination of 3 digits, the end result remains the same. The end result remains the same. So your doubt of taking it as individual digits 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 1 plus 0 plus 1 plus 1 plus 1 plus 2 plus, it is as equivalent to taking 2 digits at a time, 3 digits. The input might be different. The way you add the digits might be in a combination of 1 digit or a 2 digits or a 3 digits or a 4 digits. The end result will always be the same. That is what I wanted to tell you through this problem. You don't need to do the individual digits and add it. You can take it in any group that you wish. The answer still remains the same. I hope the idea is clear. So for 9, what is the answer? We got 3, which is very, very important. Question 2. Question 2. Find the remainder when it is divided by 36. Whenever you get a composite number, preferably a 2-digit number or a 3-digit number, write the number as a product of two coprimes, which is nothing but 4 and 9. 4 and 9. Let us do the divisibility rule for 4 and 9. Divisibility rule for 4 is last two digits should be divisible by 4. Last two digits is 42. 4 tens are 40. Last two digits is 2. For 9, we got the remainder 3. I hope it is clear. Divisibility rule for 4 is last two digits should be divisible by 4. Divisibility rule for 9 is last sum of the digits should be divisible by 9. We got a remainder 3. Number when divided by 4 gives a remainder 2. The same number when divided by 9, it gives a remainder 3. 4a plus 2 and 9b plus 3. So 4a is nothing but 9b plus 1. 4a is nothing but 8b plus b plus 1. 4a is divisible by 4. 8b is divisible by 4. b plus 1 should be divisible by 4. b minimum value is 3. Substitute here. 9 3s are 27. 27 plus 3, 30. The lowest possible value is 30 and the form of this number is 30 plus this number is divisible by 4 and 9. 30 plus LCM of 4 and 9. LCM of 4 and 9 is 36k. 36k plus anything when divided by 36. Answer is nothing but 30. Answer is nothing but 30. I hope it is clear. 4a plus 2. Please see this equation once again. 4a plus 2 equivalent to 9b plus 3. 4a is 9b plus 1. 4a is 8b plus b plus 1. Divisible by 4, divisible by 4. b plus 1 should be divisible by 4. b minimum value is 3. Substitute the minimum value wherever the b variable is there. 9 3s are 27 plus 3, 30. Now a smart student might ask me a value. Why can't I take b value as 7? 7 plus 1 is 8. 8 is also divisible by 4. You can take b value 7. If I take b value 7, the value will become 9 7s are 63 plus 3. 63 plus 3 is 66. 66 when you further divide by 36, answer again will come down to the value 30. I hope it is clear. You can take any value of b. The answer will be greater than 36. Further divide by 36 so that you will get the answer. So it is as equivalent to taking the minimum value and finding a value which is less than 36. You take b value 7. 7 9s are 63 plus 3, 66. 66 is greater than 36. 66 when divided by 36 is remainder will be 30. I hope the idea is clear. Very, very beautiful questions starting from basics. I am sure most of you are enjoying the class, right? This we call it as a thematic based learning. Question number 3. Find the remainder when it is divided by 45. 45 is nothing but 5 into 9. Same thing try to do, sir. 5. 5 means unit digit will be 0 or 5. Unit digit is 2. So 2. Answer when divided by 9, I got a remainder 3. So one is 5a plus 2 and another is 9b plus 3. Both will represent the same equation. So 5a equivalent to 9b plus 1. 5a equivalent to 5b plus 4b plus 1. I hope you are understanding how am I writing the equation. Divisible by 5, divisible by 5. 4b plus 1 should be divisible by 5. b minimum value is 1. b minimum value is 1. So answer is 9 plus 3. Answer for this question is 12. Answer for this question is 12. I hope the idea is clear. 45 is a composite number. Write the composite number as a product of two coprimes 5 and 9. Divisibility rule of 5 is unit digit should be 0 or 5. I got 2, so it gives a remainder 2. Divisibility rule for 9 is sum of the digits should be divisible by 3, so 9b plus 3. 5a plus 2 equivalent to 9b plus 3, 5a equivalent to 9b plus 1. These are divisible by 5, divisible by 5. This should be divisible by 5. B value is 1. 9 plus 3, answer is 12. Idea clear? Third question. I hope the idea is clear. Fourth question. Find the remainder when it is divided by 11. I will tell you two rules. Now, divisibility rule for 11. Divisibility rule for 11. Divisibility rule for 11. Method 1. Method 1. Now if you observe, remainder when 10 square divided by 11. I will tell you when I am discussing Fermat's theorem, why am I taking 10 square directly. 10 square is 100. 11 nines are 99. Remainder is 1. Remainder is 1. Remember this, 10 square divided by 11 is 1. Suppose remainder 1, 2, 3, 4 divided by 11. This is nothing but remainder of 12 into 10 square plus 34 divided by 11. 10 square divided by 11 is 1. 34 plus 12 is 46. 34 plus 12 is 46. That means the divisibility rule for 11 is start from right hand side. Start from right hand side. Take a group of 2 digits. Take a group of 2 digits. Add them. Take a group of 2 digits and add them. This is the divisibility rule for 11. Start from the right hand side. Start from the right hand side. Take a group of 2 digits. Add them. Why am I taking a group of 2 digits? It is based on this concept. Remainder when 10 square divided by 11 is 1. I hope the idea is clear. Suppose one example. 11, 12, 13, 14 divided by 11 is there. Take a group of 2 digits and add them. Take a group of 2 digits and add them. 14 plus 11 is 25. 12 plus 13 is 25. 25 plus 25 is 50. 50 divided by 11. 11 fours are 44. Remainder for this question is 6. Like that, you can take a group of 2 digits, keep on adding the doublets. Keep on adding the doublets. This is one way to find the divisibility rule for 11. I hope the concept is clear. I will tell you multiple ways. This is the method 1. Method 2, our textbook way. Divisibility rule for 11. Divisibility rule for 11. Textbook way. Suppose if it is ABC is there. A is there in hundreds place. B is there in tens place. 10B plus C. This can be written as 99A plus 11B plus A minus B plus C. Can I write like this? 99 plus A is 100A. 11B minus B is 10B plus C. If ABC is divisible by 11, 99 is also divisible by 11. These also divisible by 11. A minus B plus C should be divisible by 11. A minus B plus C should be divisible by 11. This is nothing but A plus C minus B. A minus B plus C is nothing but A plus C minus B. Now if you see the divisibility rule of 11, method 2, if I take a 3-digit number ABC, A is there in hundreds place, so 100A. B is there in tens place, so 10B plus C. 100A can be written as 99A plus A. 10B can be written as 11B minus B. If ABC is divisible by 11, 99A is divisible by 11, 11B is divisible by 11, A minus B plus C should be divisible by 11. A minus B plus C is nothing but A plus C minus B. What are A plus C? A plus C are present in the odd places. What is B? B is present in the even place. That means just by looking at these, A minus B plus C should be divisible by 11. I can conclude that sum of odd places minus sum of even places, sum of odd places minus sum of even places should be divisible by 11. I hope the idea is clear. Divisibility rule for 11, method 2. What is method 1? Start from the right hand side, take a group of 2 digits and keep on adding them. What is method 2? Take the odd place values, take the even place values, subtract the even place values from the odd place values. The difference should be either be divisible by 11 or it should be 0. Sum of odd places minus sum of even places should be either divisible by 11 or it should be 0. I hope the concept is clear. Now we will take some examples. We will take some examples so that you will understand it thoroughly. Divisibility rule for 11. How to check by using odd places and even places concept whether the number is divisible by 11 or not. Reminder of 1, 2, 3, 4, 5, 6 divided by 11. Take the odd places. 6 is there in odd place, 4 is there in odd place, 2 is there in odd place. 6 plus 4 plus 2 is 12. Even places is 5 plus 3 plus 1. 12 minus 9 is 3. Difference should be either 0 or it should be divisible by 11. But difference I am getting in this question is 3. 3 is neither 0 nor divisible by 11. That means remainder is not equivalent to 0. Next one more example. I am writing a single digit 6 times divided by 11. What are the odd places? 2 plus 2 plus 2. What are the even places? 2 plus 2 plus 2. 6 minus 6 is 0. So the difference is 0. That means it is divisible by 11. Method 1 is start from right hand side, take a group of 2 digits and add them. Method 2 is take the odd place values, take the even place values, subtract the even place values from the odd place values. The difference should be either 0 or divisible by 11. I hope the idea is clear. See, for the prime numbers, the divisibility rules is never unique. The divisibility rule for only 2, 3 and 5 is unique. Other prime numbers greater than 5, whether it is 7, 11, 13, 17, 19, 23, 29, it could be a 2-digit prime number, it could be a 3-digit prime number. The divisibility rule of a prime number is not unique. In fact, if I have to use machine level language concept, checking whether a number is a prime number or not, or how to find whether a number is a prime number or not, what are the numbers between 1 and 2, how many stars are there in a sky, how many points are there in a straight line, this all comes under an undecidable problem. A problem is said to be undecidable problem if there exists many ways to solve a problem or if there exists no way to solve a problem. There exist many divisibility rules for prime number. You can deduce your own rules, which I will be checking it. This concept is known as theory of osculation. Don't miss this concept in session number 4, where a student who is watching the video, you will be able to find out your own divisibility rule if you understand the theory of osculation. Now, method 3. Method 1 we discussed, method 2 we discussed. Method 3. Method 3. Divisibility rule for 11, method 3. Reminder when 10 cube divided by 11. 11 ones are 11 minus 1. Minus 1 whole cube is minus 1. That means, suppose if I take an example of 4 written 6 times, 444, 444 divided by 11. Just by looking at a question itself, we can say that sum of the odd places equivalent to sum of even places. That means the number is divisible by 11. Otherwise, this can also be written as 444 into 10 cube plus 444 divided by 11. 10 cube divided by 11 is minus 1. Minus 444 plus 445 is also 0. That means the another divisibility rule for 11 is start from right hand side. Start from right hand side. Take a group of 3 digits. Take a group of 3 digits. Take a group of 3 digits. Alternatively add and subtract. This I will explain in detail when we are solving little high level problems. Alternatively add and subtract. 10 cube divided by 11 is minus 1. 444 can be written as 444 into 10 cube plus 444 divided by 11. 10 cube divided by 11 is minus 1. Minus 444 plus 444 is 0. The divisibility rule of 11 is start from right hand side. Take a group of 3 digits. Alternatively add and subtract. I hope the concept is clear. What are the 3 methods to find the divisibility rule for 11? Take a group of 2 digits, add them. Take odd place values, take even place values, subtract even place values. From odd place values, the difference should be either 0 or divisible by 11. Take a group of 3 digits, alternatively add and subtract. Idea clear? Now we will solve this question. There is a number that is given, that is 1, 2, 3, 4, 5, 6, 7, 8 divided by 11. I will solve this problem in 3 methods. Method 1. Method 1 is, what is the concept that we are using? 10 square divided by 11 is 1. 10 square divided by 11 is 1. So take a group of 2 digits and add them. If I take a group of 2 digits and add them, 12 plus 34 is 46. 46 plus 56 is 102. 102 plus 78 is 180. 180 divided by 11. 11 16s are 176. Remainder is 4. Remainder is 4. Method 1, I got the answer 4. Method 2. Method 2. What is method 2? Take a group of odd place values, add them. Take a group of even place values, add them and subtract them. Odd values, 8 plus 6, 14. 14 plus 4, 18. 18 plus 2, 20. Minus of, what are the even place values? 7 plus 5, 12. 12 plus 3, 15. 15 plus 1, 16. 20 minus 16 divided by 11. 20 minus 16 is 4. 4 divided by 11. Answer is again 4. Method 1 gave you the same answer. Method 2 also will give you the same answer. Method 3. What is method 3? Take a group of 3 digits. Alternatively add and subtract. 1, 2, 3, 4, 5, 6, 7, 8 divided by 11. Take a group of 3 digits. Alternatively add and subtract. 678 plus 12 is 690. 690 minus 345, which is again 345. 345 divided by 11. 11 3s are 33. 15. 11 1s are 11. What is the remainder? 4. 3 methods, same answer. Generally in our school days only method 2 is taught, and most of the students tend to think that there exists only one divisibility rule for 11. Again I am repeating a most important key point. Divisibility rule for a prime number greater than 5 is not unique. For 2 and 5 it is fixed. Beyond 2 and 5, any prime number divisibility rule, there are many rules. This is one such classical example. Now, another beautiful question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 12 and so on up to 42. It is divided by 11. The reason why I introduced multiple methods to you is, reminder when you divide a number by 11. Suppose if you used odd places. You try to solve this question by using the method which is taught in your school or in your coaching center. Take the odd places and keep on adding. Take the even places and keep on adding. Check how much time it is taking. Suppose if you know method number 1, which is remainder when 10 square divided by 11, which is nothing but 1. Take a group of 2 digits and add them. So if you take a group of 2 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on up to 42. Now see here, 42 is one group, 41 is one group and so on till 10 is one group. 89 is one group, 67 is one group, 45 is one group. I hope it is clear, right? Or I will write it like this. I will write it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on up to till 42, right? I will write it like this. 35, 36, 37 and so on up to 41, 42. What is the concept? Start from right hand side. Take a group of 2 digits and add them. 42 is one group, 41 is one group, 40 is another group, 39 is another group, 38 one group, 37 one group and so on up to 19 one group, 18 one group, 17 one group, 16 one group, 15 one group, 14 one group, 13 one group, 12 one group, 11 one group, 10 one group. That means till here we got. Next. 89, 67, 45, 32, 1. Now, from here to here, if we add 1 plus 23 plus 45 plus 67 plus 89, 10 to 42, the series is in arithmetic progression. Sum of n terms in AP is n by 2 into first term plus last term. 10 to 42, total there are 33 terms, 33 by 2 into 10 plus 42. I hope it is clear. 1 plus 23 is 24, 24 plus 45 is 69, 69 plus 67, 69 plus 67 is 136, 136 plus 89 is 225. Here the entire sum is 225. Plus 33 by 2 into 52. 52 is 26. So answer is 225 plus 33 into 26. 23 6 3s are 78. 78 plus 7 858. So this will become 8 plus 5 13. 5 plus 1 6, 6 plus 2 8. 1083 I got. Again, right? If there are any calculation mistake, please take care of it. I hope the idea is clear. 8 plus 5, 13, 8, 10, 1083. Sum of odd places minus sum of even places. 3 plus 0, 3. 3 minus 9, minus 6. That means answer for the first question is 5. Answer for the first question is 5. I hope the idea is clear. What is the concept I used here? Take a group of 2 digits and add them. That is the concept which I used. When divided by 11, I got remainder 5. Now second question. Second question. First one answer is 5. Second one, find the remainder when it is divided by 44. 44 is 4 into 11. 4 means last 2 digits should be divisible by 4. 42, 4 tens are 40. Remainder 2. 11 is nothing but remainder 5. 4a plus 2 is equivalent to 11b plus 5. 4a is nothing but 11b plus 3. 4a is nothing but 8b plus 3 into b plus 1. So b, this is divisible by 4, this is divisible by 4. B plus 1 should be divisible by 4. B minimum is 3. Minimum 3 means 33 plus 5. Answer is 38. Answer is 38. Idea clear? Answer is 33 plus 5, 38. Very easy question. First and second if you know the concept. Next one. Find the remainder when n is divided by 7, 11, 13. Now see here. Divisibility rules for extremely important slide. 7, 11, 13. What are the combinations that will come from 7, 11, 13? 7 11s are 77. 7 13s are 91. 11 13s are 143. 7 11 13 is 1001. All this one, the divisibility rule is same. That is, remainder 1, 10 cube divided by 7. If I see 7 ones are 7, remainder 3. 3 cube is 27. 7 fours are 28 minus 1. Remainder 1, 10 cube divided by 11. 11 ones are 11. Negative remainder minus 1. Minus 1 whole cube is minus 1. Remainder 1, 10 cube divided by 13. 13 ones are 13. Minus 3. Minus 3 cube is minus 27. 10 cube divided by 7 is minus 1. Why it is minus 1? 7 ones are 7. Remainder is 3. 3 cube is 27. 7 fours are 28. Remainder minus 1. 11 ones are 11. Negative remainder minus 1. Minus 1 cube is minus 1. 13 ones are 13 minus 3. Minus 3 cube is minus 27. 13 minus 2s are minus 26. Negative remainder is 1. Extremely important concept. Pay utmost attention to it. A lot of beautiful conclusions can be drawn from this problem. Now, example. Remainder 1. 1, 2, 3, 4, 5, 6 divided by 7. This can be written as remainder 1, 123 into 10 cube plus 456 divided by 7. 10 cube divided by 7 is minus 1. Minus 1 into 123 is minus 123. 456 minus 123 is 333 divided by 7. 7 fours are 28, 53, 7 sevens are 49, 4. Negative remainder 4. Sorry, positive remainder 4. There are no negative reminders here. That's my mistake. I hope it is clear. Now, from this beautiful conclusion of 10 cube by 7 minus 1, 10 cube by 11 minus 1, 10 cube by 13 minus 1, what is the rule that we can write it? The rule goes like this. The rule goes like this. Start from right hand side. Start from right hand side. Take a group of 3 digits. Take a group of 3 digits. Alternatively add and subtract. Alternatively add and subtract. This is the divisibility rule for 7, 11, 13 and its combinations. Start from right hand side, take a group of 3 digits, alternatively add and subtract. This is the divisibility rule for 7, 11, 13 and its combinations. Now another important conclusion, we will do it after taking this example. 1, 2, 3, 123. 123 is a 3 digit number. I am writing this 3 digit number twice. Divided by 143. 143 is 11 into 13. Remainder 1. 123 into 10 cube plus 123 divided by 143. This is minus 1. Minus 123 plus 123 is 0. Extremely important point. Any 3 digit number written twice. Any 3 digit number written twice. Any 3 digit number written twice is always divisible by 7, 11, 13 and its combinations. And its combinations. This one is very important. Start from right hand side, take a group of 3 digits, alternatively add and subtract to get the divisibility rule for 7, 11, 13. Another beautiful conclusion is any 3 digit number if you write twice or not only twice, even number of times. Any 3 digit number written even number of times is always divisible by 7, 11, 13. When I say it is divisible by 7, 11, 13, remainder will be 0. One example. For example, remainder 1, 152, 152, 152. Written 82 times divided by 91. 152 is a 3 digit number. Any 3-digit number written even number of times, what will be the answer? 0. I hope it is clear. Suppose 888888 written 49 times divided by 13. Now think logically. 88 written 49 times is nothing but triple 8 written. This is nothing but triple 8 written 16 times and one more 8. Are you all with me? And one more 8 divided by 13. Yes or no? 49 can be written as 3 into 16 plus 1. 3 is nothing but 8 written 3 times. If 8 written 3 times is nothing but a triple 8, which is a 3-digit number. If a 3-digit number is written 16 times plus one more 8, this is 0. Answer for this question is 8. Answer for this question is 8. Any 3-digit number written even number of times is always divisible by 7, 11, 13 and its multiples. Are you all with me? 7 into 11, 7 into 13, 11 into 13 and 7 into 11 into 13. Idea clear, right? Another beautiful conclusion. Suppose if I write a single digit 6 times divided by 77. Take a group of 3 digits alternatively plus minus. 222 minus 222 is 0. Another beautiful conclusion. Any single non-zero digit written in multiples of 6 is always divisible by 7, 11, 13 and combinations. Are you all with me? 77, 91, 143, 1001. If there is a single digit and it is written in combination of 6 multiples, 6, 12, 18, 24 and so on. Suppose 5555 is written 84 times divided by 1001. 5 is a single non-zero digit. Is it written in multiples of 6 times? 84 is 6 into 14. So what will be the answer? 0. Extreme important 3 conclusions. What is the divisibility rule of 7, 11, 13? Start from right hand side. Take a group of 3 digits. Alternatively add and subtract. That is the first divisibility rule for 7, 11, 13 and its combinations. Second rule. Any 3-digit number written in multiples of 2 or any 3-digit number written even number of times is always divisible by 7, 11, 13. Second. Third. Any non-zero single digit number written in groups of 6 is always divisible by 7, 11, 13. Idea clear? Perfect idea? Right. Now we will solve with these 3 understanding some problems. Now all the problems will become very, very easy if you understand it. First question. Find the remainder when n is divided by 7, 11, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Take a group of 3 digits. Take a group of 3 digits. Take a group of 3 digits. Alternatively plus minus. Alternatively plus minus when divided by 7. If I do plus minus, 102 minus 1, 1 is 11, plus 789 minus 146, which is nothing but 333. 456 plus 333 is 789, plus 333, plus 123. 123 plus 11 is 134. 134 plus 333 is 467. 134, 467. So remainder when 467 divided by 7. 7 6 are 42. 47. 7 6 are 42. Answer is 5. I hope the idea is clear. 7 6 are 42. 47. Answer is 5. First one, it is 5. Now this 467 is very important because with this we can do all the other questions. Second question. 467 divided by 11. 11 minus 6, it is 5. Third one. 467 divided by 13. 13 3s are 13 9, 77. 13 5s are 65. Answer is 12. I hope the idea is clear. Why? Because the divisibility rule of 7, 11, 13 remains the same. Take a group of 3 digits, start from right hand side, alternatively add and subtract. Alternatively add and subtract. I hope the idea is clear. Now before we close the session, what are the concepts that we discussed today? The concept that we discussed is divisibility rule. Divisibility rules we discussed. Divisibility rules. First we discussed for 2, 5 and 10. Then we discussed for 2 power n, 5 power n and 10 power n. Then we discussed the divisibility rule for 3, 9. Then we discussed the divisibility rule for composite number where it can be written as a product of two coprimes. Product of two coprimes. Then we discussed the divisibility rule for 11. Method 1 we discussed. Method 2 we discussed. Method 3 we discussed. Then we took an example. Then we discussed the divisibility rule for 7, 11, 13 and its applications. These are the concepts which we discussed in divisibility rule session 1. I hope all the concepts are clear to you. Just I am rewinding it right from the beginning. First we had found out how to find out the divisibility rule for 2, 5 and 10. Then we found out divisibility rule for 2 square, 2 cube, 5 square, 5 cube, 10 square, 10 cube. Then we found out divisibility rule for 3 and 9. Then we did it for 18. 18 is 2 into 9. How to find the equation. Then we discussed a very important concept. Instead of taking single digits, you take it in doublet, triplet, singular format. The resultant digital sum does not change. 9, 36, 45. 36 is 4 into 9. 45 is 5 into 9. Divisibility rule for 11, method 1, method 2, method 3. Method 3.